to do 3.4 notes. You should have grabbed this. Chromebooks need to be closed. The sheet was back there if you didn't grab it. Make sure you have it. Dalton, can you close your Chromebook, please? And thank you. All right, so this first one just says that if you do two rigid motions, then it still is a rigid motion. Okay. If you did three rigid motions, it's still a rigid motion.
So no matter what, it's a rigid motion. If you keep it rigid motion.
Four translation.
Okay. Say again.
It's four translation.
Four translation. I'm not sure.
Is four a translation? Because if you reflect it four times, it would be the same.
So this is just a rigid motion means, what does rigid motion mean? Okay.
It means they're just moving it across
rigid motion, correct. Rigid motions are reflections, rotations, translations. But how do you know if something's rigid?
If it's side length and angle measurements are the same.
Yeah, it still is the same shape. Okay, it's just in a different place. Okay, so if one side gets smaller or one angle gets smaller, then it's not a rigid motion. So that's basically all it's saying is if you do a bunch of rigid motions, it's still considered a rigid motion. Okay, just has to look the same. So here, I like these questions. It says, what is the two rigid motions that cause this shape to end up where it is? Now, if this was on the test, I would have to accept any answer that was correct, and there might be more than one way of doing it. Okay? So, yep, I'm listening.
What if you do a reflection over x equals -1?
Okay, reflection across x equals -1. So I'm going to go ahead and draw that x equals -1 on here.
And then do another.
Hold on, let's just do one at a time. So that would make this thing, if it's 2 away from there, it would be 2 away there. It'd be C would be there, B would be there, and A would be 4 away, would be there. So that would be our new shape. That would be our first one. And then what would you do? Okay, how?
2. No. It's down, but I don't know how to use it.
Okay. You don't feel like what?
I forget. Do you do it from the bottom or the top?
Well, this point here would have to end up here. So it's down 5. Okay. So then it's down. What if I just do an arrow and write 5? And we know that that's going to be a negative. I like that. So that's kind of our cheat sheet to answering this question. So first off, I'm doing it to triangle ABC. Okay. And remember, we work backwards, guys. I'm not going to have patience for this today. Okay. So we're going to work backwards. What did we do first is going to go here. Reflect. What symbol do we use for reflection? Capital R. Okay. And we do a little subscript that we reflected across what?
Y. X -1.
X equals -1. Okay. Composition. That was what we did first. Remember, we go backwards. And then what did we do next? Translation is that, how do we represent translation? Capital T. And then we use it little, I don't even know what these things are called. It's a weird parenthesis, but it's almost like an inequality. Yeah.
You should call it the sharp.
Okay, so the question is, it got moved down 5. Is that for the X or is that for the Y that moved down 5? It's for the Y. So for the X, I'm going to say move it how? 0. And for the Y, I'm going to say move it negative 5. Okay, is that big enough to see?
Can you have reflected that shape across the x-axis? No, never.
Okay. Now, when I say there's more than one way to do it, you could have, in this case, the order wouldn't have mattered. You could have moved it down 5 and then flipped it. Okay. Sometimes the order matters, sometimes it doesn't. You could have flipped it across the y-axis and it would have been off, but then you could have moved it down and moved it back left. Okay. As long as it ends up where it's supposed to, there's more than one way. I think this is probably one of the more efficient ways, but you know, it's like parallel parking. Have you ever been in the car when your parents are parallel parking and they do it, it takes them like 10 tries?
Yeah.
They still got there. Okay. So however you get there, as long as you still get there. Okay. Did you have a question?
My dad's like, it takes him one try to get into a parallel parking space. It's amazing.
Okay, so now they're going to ask us to follow one of their rules, okay, and to see what happens. So I'm sorry that this graph is so small, but it is what it is. So it starts at -3, 2, or we got to plot these 4 points. So -3, 2, 0, 5, 4, -4, and 0, -2. And using a straight edge or not, we're going to connect these dots. Now, I think it's super important that when you do reflections, don't do what I initially said. I like somebody else's advice. I think it's Brody who said, let's just do the dots and then connect them. Is that you? Okay, so that's actually a really good idea to do this. So we're going to reflect across the x-axis. And some of you are uncomfortable with the fact that if we reflect across the x-axis, then that actually means that the shape is kind of reflecting on itself. Okay? And initially, we were really confused by that. And remember that we go backwards, so reflecting this first. Okay, so reflecting across the x-axis, this point here will end up being, if it's 4-way there, it's going to be 4-way here. So that point becomes positive 4, 4. Yeah. Okay. I like to just kind of look at it, but we do have rules that just say make it the opposite, okay, of the x. This one's going to flip to there. And this one's going to flip to there. And this is going to flip to there.
What's the 4, 4?
Did I make a mistake?
Yeah, it's on 5.
Yeah,
4, 4. It's too high. Thank you. Having a different color when you do these would be very helpful. Okay, so I'm going to go ahead and connect those dots, and I'm going to do it really light. I like to see the final shape because I don't know about you, but when I see the final shape, I can tell kind of by looking at it that it was a rigid motion. Okay. And when you ask me, hey, is this right? I look at it first and go, something's off. I can just tell. Okay. Or, yeah, it looks right, but I'm not actually checking every step. Then the next thing it asks us to do is to move it x +1 and y 0.
So you just do 1 over right.
Scoot 1 over right. So our x is going to get moved up. Really wish I had a different color.
Mine are all dark.
A million Sharpies, but that's going to get. So then it gets moved +1. So then we're going to move it. This point gets there. This point gets there. This point gets there, and that one gets there, and then I'm going to connect them. Okay, so that pencil is my final answer. The pen was the reflection across the x-axis.
Yeah, that's actually weird.
So why do they do it, like, on a test, do you want all three shapes or just the final shape?
I think I would want all three. Because if you didn't answer, if your final answer wasn't correct, I'd want to, it's kind of like showing your work, showing your steps.
You might as well just give me an F right now.
Might as well.
Actually, I think I might earn a D minus.
So,
Maybe.
personally, this is what makes this really, really challenging. If you can't see the reflections, or if you can't see the translations, it's really challenging to kind of get, but it got reflected down and then shifted over, okay? On Friday, we're going to kind of play with these, I think, and you're going to have no tools, we're going to just, it's like going to be like pin the tail on the donkey, right? Do you know that game?
Yeah.
You know?
I played it once. I played
Okay, so
Pin the Word on the
You
Witch.
get blindfolded, there's a donkey on the wall.
I don't know what that is.
And you try to put the tail in the butt.
I did Pin the Word on the Witch.
It's not a real donkey.
Yeah,
Mark, you're so dumb.
No,
No, he's a
How would-
Russian. They might actually do that in this country.
Maybe it's because
This kid, you poke it.
All right, so here's the point is pin the tail on the donkey is fun.
But they're dangerous.
Refocus.
If you put
Guys, pin the tail on the donkey is fun, but it's fun because sometimes people are ridiculously off, right? We're going to play pin the tail on the donkey rigid motions on Friday, and some people will have it very precise and some will be way off. But we need to be able to visually think in our brains, almost do reflections and translations, okay? The next one.
How many years have you been teaching?
This is my 17th.
17.
Did you get your master's in college?
All right, so I kind of like these ones because they're a little less ugly. Actually, I like both of them, but what words are on here that we've maybe not discussed before? Glide reflection. So they call them glide reflections. It just means that there's more than one thing that's happening. And they call it glide because they're, I don't know, they chose that word because it's like, it's not just a straight reflection, but it got kind of moved in multiple ways, okay? So glide reflection just means a composition of rigid motions, okay? So again, there could be more than one way of answering this. Okay. I didn't say anything.
I tried it one day.
Oh, I think I know.
Okay.
So I think that if it was going to be a glide refraction and it would be rotating, it would be over 0, 1.
Okay.
Because it's the rotating. Wait, no, that can be weird. It looks like it would, but it just wouldn't. Wait, no, it would be a -1, 1, I think.
All right, so let me say this about glide reflections. And I might be confusing, but I think the glide reflection implies that there's going to be a reflection in there. And then what would you imagine the glide being? It's not rotation. Translation. So glide reflection does not include rotations. Okay? And let me tell you, rotations are the hardest ones to predict where it's going, right? So if I go 34 degrees, it's going to be so hard for you to find 34 degrees. It's going to be like you're going to have to get all kinds of tools out and stuff, okay? So in other words, we need a reflection and a translation to get the first shape onto the second.
You have to do it backward. Do you have to like do the reflection first or the?
Doesn't matter.
So like, it could be reflected over like Y1.
Okay, it's clearly got to be reflected over Y something, right? Or X-axis. It's got to be reflected this way so that these J and L end up top, okay? So Ryan said Y equals 1. I'm just going with it. I don't think you can do it wrong. So if it's reflected there, again, reflection means this is three dashes away from this. So this point here is 3 dashes up here. This is 3 dashes away from this here, so it's 3 dashes up there. And even though we don't like this, it can reflect the other way. When we use the mirror, it's really hard to do these reflections, okay? But that point ends up being there. And then I like to make because this isn't my final result, make it nice and light, okay?
And then your glide part would be X, 1, 2, 4, 2, 3, 4, 5, Y 0.
Okay, so then we got to move it this way. 5. Would it be a positive 5 or a negative 5? So I'm going to put positive there. We don't have to put positive in our answer, but just so I know it's not negative. Okay. I'm going to write it underneath here because I want to have a lot of room. First of all, it's triangle JKL. So that's what's getting affected. We did a reflection, which is what letter?
No, capital R.
Capital R. We did a reflection across Y equals 1. I was at a math meeting and someone wrote the Y equals 1 large. And I was like, I couldn't even look at it. I was like, can you erase that and make it small? And she was like,
Did you do it?
She did. She didn't like me though.
When was your math meeting?
2 Fridays ago. And then, okay, capital T, right?
5 and 0.
5, comma 0. Is that right?
You don't need an alligator comma.
Just call it a half diamond.
Is that the prickly gummy bear?
No, it's right there.
That's Scary Brutus.
Why do they have red eyes?
You can ask my 4-year-old daughter.
Why do you look like?
Because
It's
the
already
kids
out.
aren't, but don't you see it has 2 daddies?
Yeah, it would be really
That's
creepy if that
disrespectful.
wasn't.
I mean, you gotta go like she can draw her iPad because I'm horrible.
Hey, it would only be creepy if that wasn't his kid. Just think about that.
So mean.
Not me. I'm
The
just.
other way, it's not creepy because it's his kid.
Okay, so what's next?
All right, so next one here, we got to plot these points. It's a triangle, so we have 3 points to plot. I did get you some regular graph paper, by the way, so you probably want to take a couple pieces of that for homework. -3, +4, -4, +2, and -1, +1. So there's my starting off triangle.
A right triangle.
Is it right?
Yeah, it is. Yes, it is.
$1 million question. Does that matter whether it's a right triangle? It does not. Okay.
It's just a fun fact.
I get $1 million.
1, 1 is my A. It's probably important to label your A, B, C so that you can kind of figure out.
Wait, what? 1, 1.
1, 1 is our A prime.
Oh, that's a C.
2, negative 1. It's our A.
What's going on?
I'm plotting my A prime is right here.
They got rotated 270.
I don't know if it's points correctly labeled. You got it. Flip it over -1.
Then negative.
Reflect. What are we reflecting? Somebody. We reflect over.
Okay, hold on.
Okay.
Let's make sure they get the drawing down.
I swear, these people are like not very smart. I remember last year when 11 was at lunch, but now everything makes me wait
Can you guys stop talking, please?
So I'd like you to, on your own, which means no talking, try to figure out this glide reflection. The first part is you kind of want to map it out, what you think is going on the graph. And the second part is to then put it in the correct notation. Hush.
Wait, wouldn't that be Y?
I have a question. How do you get why can X be 1 instead of -1?
If you do that, then your transformation will be different, which is fine. I would have to accept it as long as it was correct. I don't think it'd be the most efficient glide reflection. Okay, but if you had it to be +1, then it would reflect it over here, over this line, and then it would end up here roughly. And then you'd have to move it down and left. That wouldn't be wrong. As long as you, it's like parallel parking, right?
Why we couldn't do 1 or
I did X equals 0.
And did a, so it's like parking the car, right? Is I'm going to say, move this car from here to there. I'm going to turn away and not watch you. And then when you say you're done, it's got to be in the right spot. If you've moved it 100 times, that's fine. The only thing I think that we would ask is that you don't do more than 2 compositions, okay? So we shouldn't have to move it 15 times to get there. Go ahead and see if you can figure out this one.
I was supposed to go with the x -1, but I moved up. You moved down.
You reflected. You reflected this way.
I reflected this one to here, and it has to go up 3. You did the same. You said x -1 too. How'd you go down 3?
So ABC is this shape. ABC prime is here. That means you gotta move this shape to there.
Oh, so okay, so it is. I was thinking of I thought I was making it this shape. Okay.
Yeah, if I switched those primes, then you would have been right. Okay, what does this say? Are we able to do it?
Guys, stop. I rebuke that negative energy.
Not without rotation.
No, we cannot do it yet.
So how is this different?
It's not a rectangle.
It's segments instead of triangles.
It's so wide.
Ben was the only one who said the right
I
word.
said it too.
I said it in my.
It is a segment.
Yeah, that's what I was gonna say. I was just trying to draw it. Like,
Okay, so it's just a segment. Now, the less complicated the shape is, the more kind of flexibility you might have in how to do it. So if it's a dot, you might be able to do it differently than a shape, okay? Because a shape has like maybe a pointier part. That pointier part needs to identify with that. But okay, so plot these points, -2, 4, and 2, 6. And Brody made a good point that it's really important to know that this is our starting shape. And I'm asking you to move that shape to the prime location. It doesn't say that, but it implies that the prime is the new shape. So 0, -6, and 2, -2. Okay. That's a good point. Do you believe we have to use a rotation?
Or maybe we could rotate it along something
I
like,
got it wrong with my foot.
x equals, y equals x plus or minus.
You know what I'm
also, it's dogmatic.
What?
What happened?
Where's my name?
I'll play Madden drawing.
Actually, that's good.
Hey, no. Well, that's always the last one.
Anybody have any ideas? So I looked it up in the book and realized, okay, my first question to myself in the book was to make sure the glide reflection, and it says,
The line got smaller. I went the wrong way. How do I know it's gonna go?
Yeah, it did.
It's the same amount of units as the sharper slope.
Yeah, so that means it is a rigid motion.
yeah, so it is a rigid motion. So the first thing I had to look up was, is it got a rotation? It does not. They do it without a rotation.
But the line is gonna be.
If you turn your paper sideways with the bottom one, it's the exact same. So like,
Who said longer?
Nothing.
why?
Mine used to be longer than both yours.
So here's a question, guys. We're not talking about hair. Here's a question: when does a reflection not move something?
When it
When
when it rotates 0 degrees.
Now rotation, when does the reflection,
When it's on top of it.
when it's on top of itself?
0, 0.
So this is what I propose. Let's move R onto R prime first.
Okay, so you gotta translate it down first.
So if we move R to R prime, so first of all, our shape is RS, and I want to first do a translation where R is going to land on R prime.
It's down 10 over 2.
Down 10 over 2. So how do I write that?
Negative 10 positive.
Negative 10, I think, would go this way, because that would be X.
Oh,
So it's a
2
negative.
negative 10.
2, negative 10. And that would take this shape and move it to here. It would put it right there. That R would land right there, but then the S would be up to, it would have the same slope, would end up right there.
S is just down 8 though.
You need to reflect it.
Okay?
Over what?
Some of my counselors
Can you see that? That pencil mark?
tell you like
You can have to rotate. You can use my pencil if you want. Here you go. His pencil's better.
Wait, your pencil one's too high. It should be down one more.
I thought it was, didn't look rigid, did it?
Not really.
We got this. We got this.
And
Okay, so to figure out where that ended up, it went up, the slope doesn't change. So it went up 2 and over 4, up 2 and over 4. Thank you.
can we just completely skip the reflection part and translate again?
Translating again is not going to change the angle. But if I had a mirror,
you just reflect it. They'll put that point right there because the point is shared by both lines. So
yes,
reflect right over.
if I put a mirror on here, where would you put the mirror? It would be on the R, but where would the other part of it be?
S prime.
If you put it on the S prime,
Like between the midpoint.
it'd be the midpoint.
Yeah. So.
That's what reflections do, is get to the midpoint and then keep going.
The modern family.
So this is where I would want a straight edge. This is where I'd want a straight edge and put it on here that it would be exactly in between those points. That's where I would want to reflect. It's right in the middle. So x equals, what's my slope of that? 1. X, what's my y-intercept? -6. So my reflection is y equals 1x. I didn't have to write the 1, but I did. Don't judge me. So when in doubt, put one dot on the other, and then you can reflect it. Okay, because the reflection is in the middle. So if you can figure out where that reflection is. Does everyone see what happened there?
Yes.
Not at all.
Dalton, you're the one who came up with it.
I'm just kidding.
Ah, it's hilarious. I love it.
That was so funny. That made me chuckle.
That
That made me so funny.
Why do we need to know this?
Honestly, I was thinking about this yesterday because somebody told me in this class that they want to be a accountant. Okay,
Andrew?
and they said an accountant.
Listen, he's about to tell you.
So, and I thought about it, and honestly, here's the thing about being good at math. If you become a auto mechanic, I would rather have an auto mechanic that's good in math than one that's not. And let me tell you why. Because if they could walk through this problem we just did and understand it, then when they look at your car engine and they're trying to figure out what's wrong with it, they're going to be able to walk through in their brain.
Rotation and translation. How is that? What?
This is practice. Let me. All right.
Remember when you told us about the pool? It's sort of that same situation.
Yes. So, soccer players, they like to tell you how many times they can juggle a ball. In a soccer game, how often do you see a soccer player juggle more than twice?
567,420.
Like
None. So, there is a relation to being able to move your feet in that way or to think in that way to then also be able to think in other ways. It's just practice. It's just getting good at something. Okay? You can believe me all you want, but I'll tell you what, if you were a school teacher and you had a math student and they were awful in math and you walked into an auto shop and they were working there and they say, I'm going to work on your car and figure out what's going on, you'd say, can I just get an estimate? Because I might go somewhere else.
What if they're gifted with this thing, not gifted with math? Because I have a friend who can do like, I forget what it is. They're like,
So my point is that things don't translate exactly. Okay, things don't translate exactly, but being able to do this stuff and being an accountant, there's a degree of creativity in this mathematics. Okay, you want to be able to think in different ways. Accounting, I could teach, a computer can do accounting and can kind of just do all the work, but it can't be creative. Okay, geometry is the creative side of mathematics, whether you like it or not. Huh?
They work with numbers.
They work with numbers. So,
They work with numbers.